Hello, my pre-calc classes. This is Mrs. Meyer. I feel like I need to reintroduce myself as it has been several days since I have seen you. Yes, I just shut my door because I don't want anybody to walk in because I'd be like, this is like really weird that I'm talking to myself. But anyway, I just hope that you guys know that I would not be absent this many days if it wasn't that important to me. So I'm just spending some really quality time with my mother right now, and years down the road I'm going to look back and I will live with no regrets over that. And I just hope that you guys understand that. And I know that what we were doing previously in 5-1, the instruction had been given. And so I felt confident in the group quizzes. You guys rocked those. That's awesome. I have not yet graded the regular quizzes yet, but I will get to that ASAP and let you know. But a few people that I've talked to has thought that they did really well on that. And so I just trust you guys on all that. But we are moving into 5-2, and I am going to try something new. I have never in my life done this. I've always wanted to vlog before. My daughter's telling me, Mom, are you crazy? But maybe this will be my introduction into it. Obviously, I cannot hold the camera very steady. I'm probably making you guys dizzy right now. But suck it up, Buttercup. Here we go. Anyway, so I'm going to try this, see what happens. I do not know who your sub is going to be the next couple days. But Winking and Medemeyer are always there for you to pop in and ask questions. Trust me, I will thank them with food. You know, that's always the way to get somebody on their good side. Anyway, so here we go. So I want you to have your notes out on 5-2. And what I have confidence in is this set of notes is very similar to what we did in 5-1. The difference is that we are actually proving that the left side of the equation is equivalent to the right side of the equation. And what's kind of funky with these notes is that actually our hints are down at the bottom or in the middle where it says the strategies for proving this identity. And so it says to first begin with the more complicated expression and work towards the less complicated expression. And so we're going to actually start with probably one of the more difficult ones. And so this one is actually much more difficult than the one over here to the right. Why? I have no idea, because that's just the way it was on the paper. Anyway, so obviously the left side looks much more difficult than the right side. So this is what we are going to be trying to prove is this 1 minus x, okay? So what we're going to do is we're going to use algebraic methods to solve the left side to get it equivalent to the right side. And so to do that, I'm going to first, I notice that we've got a fraction here. I'm not going to really worry about that fraction for right now, but I notice that I have two binomials, and I'm going to use FOIL in order to multiply those out. All right, let me just see how well I can write and hold this camera at the same time. Okay, so here we go. So I'm going to leave this fraction exactly as it is. It's x cubed minus x squared. The negative is going to come out in front, and then foiling, I'm going to take x times x, and I get x squared. X times positive 1 is a positive 1x. Negative 1 times x is a negative 1x. And negative 1 times 1 is a negative 1. Okay? And that's going to equal my 1 minus x. I hope, anyway. Let me fix my little x here. Okay. So now I have that foiled out, and so I see this negative out in front. I want to get rid of those parentheses. So I'm going to distribute that negative to everything inside of those parentheses. But before I do that, notice my positive x and my negative x, those cancel. So negative times x squared is negative x squared, and negative 1 times negative 1 is a positive 1. And that is going to equal this 1 minus x. And you can bring that down all the way through. You can leave it empty if that confuses you, because typically as we're solving equations, we want to set it equal to 0. This is not the same thing as that. We are proving that the left side is equivalent to the right side. So the right side is going to stay put. And the reason why I say the right side is because the right side is the simpler of the two sides. If these were flip-flopped, then I would be leaving the left side the same and solving on the right side. Okay, everybody with me? So I'm leaving this exactly where it is. Okay, so now x cubed minus x squared over x minus x squared plus 1. All right, I notice, do I get a common denominator for all this? Absolutely, I could. But I think I'm going to go with factoring the top here, because I can pull out an x squared on the top, and I'm left with x cubed times x minus 1 over x. I just pulled out a greatest common factor from that, okay? And what that does, what I'm noticing is by pulling out a common factor, I'm going to cancel that. So I don't even have to deal with a denominator. I don't even have to deal with a fraction, so I don't have to worry about a common denominator, okay? Equals my 1 minus x. All right, so canceling out this x, and the reason why I can cancel is because these on the numerator are being multiplied together. Therefore, they are factors. Factors can cancel. So I can get rid of that square, and that cancels. And look what I'm left with. I'm left with, and I'm running out of room, x minus 1 minus x squared plus 1 equals 1 minus x. All right, so now I have, actually, I just messed up. Okay, hopefully this doesn't go viral. I missed this x out in front. So x times x minus 1 is x squared minus x squared plus 1. Okay, let me back up for a second. What I didn't do is multiply this x times this x minus 1, and when I went down to rewrite it, I'm a little brain dead lately. So x times x is x squared. X times this negative 1 is negative x. Okay, I just distributed this x out in front to this numerator. That's all I did. Okay, and then I got x squared minus x squared plus 1, hopefully equals 1 minus x. And notice my x squares cancel. I get a positive 1 minus x, which is exactly what I have here, so it checks. That's what I'm looking for. I'm looking for the left-hand side, solving algebraically, to equal the right-hand side. All right, and the reason why I'm saying left and right is because the left is much more complicated than the right side. Okay, let's look at the second problem. 1 minus x minus 1/2 equals 2 minus x over 2x. Both of these look a little complicated, but the left does not have a common denominator where the right does. So I'm going to say, my personal opinion, is that it's easier to work with the left. It's a little bit more complicated because it's not in common denominator form. So I'm going to get a common denominator of 2x. So I need to multiply both numerator and denominator by 2. So I'm going to 2 over 2x. This fraction has to get multiplied by x over x to get the common denominator of 2x. So I get x over 2x equals 2 minus x over 2x. And notice how nice and neat this is. My numerator is 2 minus x, common denominator 2x. And by gosh, by golly, look at how nice and simple. Mrs. Meyer, why didn't we just start with that one to begin with? You know what? Because we just sometimes tend to make things more difficult than what they are. Anyway, so that is a very simplistic way in which we're solving. This one was much simpler than the first one. Okay? Okay, so now moving on. This says to graph, determine if the following are identities by graphing, and making sure that we're in radian mode since we have our pi involved in here. And so therefore, if you want, go ahead and you could graph cotangent x times sine x as y1 and cosine as y2, and then see if that actually equals each other, is the same graph. You can determine that. I also would like you to do it algebraically. So we start out by converting everything in terms of sine and cosine. Cotangent is cosine x over sine x times sine x over 1. Does that equal, I could put a little question mark there, that actually kind of makes it cute. Does that equal cosine x? My sine x's cancel, and I'm left with cosine x does in fact equal cosine x. So I'm all good. I forgot my little angle x there. Okay? All right, second one. Cosine times x minus pi over 2 equals sine x. And looking at your yellow trig sheet, and you will continue to use that through section 5.2 as well. Hopefully it's not too demolished. I'm going to try to get some extra copies set in the back for you. Actually, I'll try, yes. And so that if you have lost yours, or if yours is way too complicated with stuff all over it, you can get a new copy. But anyway, on your trig function, you can see that cosine times x minus pi over 2. does equal sine x. And again, if you would graph that, you would just type this into your calculator. And I highly encourage you guys to do that and to see that this graph does equal the same as that sine graph. So this would be y1 and that would be y2 using your graphing calculator to see that. If I was really talented, I would get my calculator out and show you that. But I'm going to let you guys explore that one on your own. Okay, this one's going to need a little bit more space. Not quite as simplistic as the two that we just did above, but that's all right. So we have sine cubed times 1 plus cotangent squared x equals sine x. Now, 1 plus cotangent x could use the Pythagorean identity for that, but it does not get me, by using a Pythagorean identity, it does not get me to sine. And since both of these are in terms of sine, I'm going to probably take the cotangent and convert it into sine and cosine. And you can see down here, number 2, it says, if no other move suggests itself, convert the entire expression into sine and cosine. So I think that's what I'm going to do with this cotangent. And so I get sine cubed x times 1 plus cotangent is the same thing as cosine squared x over sine squared x. And does that equal, there's my little question mark, sine x? That's my question. I want to know if it does. The 1 plus cosine over sine, I'm looking for a common denominator because I've got the 1. Hopefully you got that hint on your quiz, you guys. I felt bad I wasn't there, so I'd like to give you a little extra hints on that. So sine cubed. So I get, and I want my common denominator to be sine squared. So this 1 is going to be turned into sine squared x over sine squared x. That's equivalent to 1. Sine over sine is just 1. Plus cosine squared x over sine squared x. Does that equal just plain old sine x? Interesting. I wonder. Curiosity has me. So then, the inside this parenthesis, I do have a common denominator of sine squared, so therefore I can just combine my numerator. And I get sine cubed x times sine squared x plus cosine squared x all over sine squared x. Again, does that equal sine x? Well, by now you should know, what does sine squared plus cosine squared equal? I want to hear it as a class. Yep, it equals 1. Good job. So sine cubed x times 1 over sine squared x, if you can read this, you've been in my class this long, you should read it, equals sine x. Okay, so sine cubed x times 1 over sine squared x equals, does it equal, there's my question, sine squared. My sine cubed and my sine squared cancel, leaving me with sine x equals sine x. Hallelujah. Look at that. Isn't that cool? That all of this can condense down into that. So basically, guys, back the train up a little bit here. We're actually working these trig functions just like we did on one of those pages of the packet where the answer was given. Now, on 5.2, the answer is given, but we're not exactly sure it's the correct answer. So we know that the goal is to try to get to sine x. But if it doesn't, then we're not so sure that we made a mistake. Or is it that maybe it doesn't equal? Okay, so this pretty much is going to be our goal. That's what we're looking for. Okay, trying to condense it down into one trig function is either sine, cosine, or whatever it is that's given. And so you can kind of start out thinking, this is my goal, that is my answer, but then we just double check it after we simplify. Okay, and this last one is probably the easiest one outside of the one right above it, because sine 2x divided by 2, what happens to my 2's? They just cancel. So I'm left with sine x does in fact equal sine x. Guys, I'm really sorry this is so soppy, but it's really hard to hold a phone and write and talk all at the same time. I'm really not that coordinated, but I'm doing the very best we can, and I think that you're going to get enough of it that you can kind of get it. So hopefully on this you can rewind it as needed. Okay, so there's our strategies for proving that, and for proving the identity to see if the more complicated side equals the simpler side. Now, let's prove some Pythagorean identities. And I heard that Metemeyer was in here kind of giving away some stuff to you. You know what? Quite all right. But that's kind of what we're going to be doing down here is proving the Pythagorean identities. I don't think we're doing the cosine squared plus sine squared equals 1. We're doing the ones that are, not as necessary as that one, because that main Pythagorean identity does, from that you can derive and get all the rest of everything off of that one. And again, into his class, you are going to learn more and more and more about that. Okay, so here we go. We're going to prove these two identities, and we're going to call it a day. So 1 plus tangent squared equals secant squared. I've got tape on my finger because I was like chasing a squirrel over here and pulling tape off my desk. Okay, there it goes. So 1 plus tangent squared equals secant squared. Neither one of these, if I simplified, I'm proving it. So I can't just say 1 plus tangent squared. Well, that's the same thing as secant squared because my Pythagorean identity tells me that. No, we're trying to prove it. We can't just assume that that's true. We're going to see how that is true. So tangent, so what I'm going to do, let me back up. What I'm going to do is I'm going to convert both of these into sine and cosine, okay? So I go 1 plus tangent is sine squared over cosine squared. So I'm wondering, does it really equal secant squared? You just took my word for it. You just took my word because it was printed on a yellow sheet of paper. But now we're going to see, does it really? Okay, so now I'm going to do cosine is my common denominator. So 1 is going to be the same thing as cosine squared x over cosine squared x plus sine squared x over cosine squared x. Does that, in fact, equal secant x? Hopefully you can see where we're headed. Cosine squared. You guys are going to be like seasick by the time this is done because I can't hold this paper without moving. Anyway, I'm going to convert this step. Cosine plus sine over cosine squared. What is cosine squared plus sine squared? You're right. 1 over cosine squared. Sorry, I just skipped that step because I was moving my paper. And what is 1 over cosine squared? It is